Hi everyone, welcome to CCNA 200-301 training. My name is Chirag and I'll be accompanying you on this journey of learning networking from, I can say, from scratch to learning some advanced technologies also. So I am super excited for this training and I hope same for you. So in today's session, first of all, we are going to understand what will be the major categories which are going to be covered in the coming days. And after that, we will look deeper into how networking works, what are the basic devices which are used in configuring a network. So let me begin the session without wasting any time. And so the first thing which will be covered is network fundamentals. And after that, we will look into network access.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
Then we will talk about IP connectivity. Then after that, we will learn IP services. Then we will look into security fundamentals. And automation and programmability. So you can consider these as your major categories, which will be covered in the coming days. And under these categories, there will be some protocols and technologies which will be covered here in each category. Just a minute, guys. I hope you guys are able to see my screen. Okay. So now let's understand what will be covered in network fundamentals and after that network access, IP connectivity, IP services and all. So under network fundamentals, the very basic things will be covered. We'll talk about what is an IP address, what is a MAC address, what are the basic devices which are used in a network. So let me just write this also. We'll be covering IP. We will learn what is a subnet. And after that, we will look into OSI model. We will learn about TCP/IP and all other basic things which are required to begin the journey. After that, we will look into network access. Here we will learn about layer 2 operations. So for those who don't know what layer 2 operations are, so there are some different layers on which we work. So you can, as of now, you can keep this in mind that layer 2 will be covered in the network access. And after that, in IP connectivity, we will be covering layer 3 operations. So basically, routing table and all other things will be covered here. Then IP services will include DHCP, NAT, WAN, all these things. Then we have security fundamentals. We will learn how to configure a secure network here. And after that, we will look into automation and programmability. We will be looking into how Python can be used to configure any network. So all these things will be covered in the coming days. So first of all, let's understand why we should invest time into this. So CCNA is a certification which is provided by Cisco, and CCNA stands for Cisco Certified Network Associate, and the paper code is 200-301. So you all must be aware about changes which Cisco made in March 2020, but let's understand how things used to work before that. So basically, there are 3 levels for certifications, and with these levels, there comes some tracks. So the very first and basic level is CCNA. After that, you can pursue your CCNP. Then the expert level is CCIE. CCNA stands for Cisco Certified Network Associate. CCNP stands for Cisco Certified Network Personnel. And CCIE is Cisco Certified Inter-Network Expert. So with these certifications, there used to be some tracks also, which are routing and switching. We have wireless. We have collaboration. We have security, data center. So what used to happen before March 2020 was you were given ability to choose a track out of these available tracks to pursue your certifications. So let's say you selected routing and switching and you started preparing for CCNA routing and switching. And once you are CCNA routing and switching certified, you can then move further to CCNP routing and switching. So basically what we are doing here is we are just selecting one track out of these available tracks and then getting our certification in that particular track. So for CCNA, there used to be a written exam, which was CCNA 200 125. And there were a couple of exams for CCNP. The first one was root exam. Then we had switch exam. And the last one, which we had earlier, was troubleshooting exam. So these were the exams which were needed to pass to get CCNP certified for that particular track. After that, if we talk about CCIE, there used to be a written exam, and after that, a lab exam was there. Now, after 2020, there were some changes made by Cisco. Let's understand what were the changes. So we still have these three levels, which are CCNA, CCNP, and CCIE. And we still have the tracks. We still have routing and switching. We have security. We have data centers. And we have collaboration. So you all must be wondering, then what is the change which has been made by Cisco? So Cisco made a change basically for CCNA. They have combined the syllabus of CCNA for all these tracks with one certification, the new certification, which is CCNA 200 301. So now, at the very associate level, at the very basic level, at the very first level, you are getting introduced to all of the tracks. So basically routing and switching is 70% there in CCNA, and the rest of the tracks are just getting introduced with a percentage of 30%. And once you are CCNA 200 301 certified, then after that you can get your specific track certification for CCNP. So once you are CCNA certified, then you can just select your track as per your choice. So let's say I selected routing and switching, then I can pursue my CCNP for routing and switching, then I can pursue my CCIE for the routing and switching. There was another change done, which was routing and switching is now known as enterprise. So you get CCNP enterprise, you get CCIE enterprise instead of CCNP routing and switching and CCIE routing and switching. Now CCNA can be, the CCNA certification can be done by giving one written exam. So there is just a single written exam which you have to clear to get certified. And if we talk about CCNP, so there are now two exams. So yes, we were discussing about the exams which were needed to be cleared to get CCNP certified. So the very first exam is core exam, and after that there is a concentrated exam. So you have to clear these two exams to get CCNP certified. Now, what is this core exam and what is this concentrated exam? Let's understand that. So now with this, Cisco introduced some concentrated exam like NRC, which is Advanced Routing and Switching, NOTO, which is related to automation, and some other like an SDWAN, which includes SDWAN. So what has to be done now to get CCNP certified is you have to clear one of this core exam. So you select your track out of these. Let's say you selected routing and switching, which is now known as enterprise. So now if you want to get CCNP certified, you have to first clear your core exam of routing and switching, and with that you can select any one out of these concentrated exams to be CCNP certified. So let's say you selected enterprise and you have cleared your core exam. With that, you cleared your NRC. So now you can be CCNP certified. Now let's talk about the expert level certification, which is CCIE. As earlier, there used to be written exam and a lab exam. But now when things changed, there is a good news that written exam is not there, and the core exam which you clear in the CCNP level is same and is considered as the written exam for CCIE. After the completion of your lab exam, you can be CCIE. So this was all about how certifications work. Now let's understand what are the topics and what are the things which we are going to learn. So the very basic question which comes to my mind whenever I think about a network is, what is a network? So if I have a PC here, let's say PC A, and if I have a PC B, these two guys want to share some files with each other, but they are not connected with each other in any way. So if we connect these two with a wired or a wireless connection, let's say we just connect them with a wire, with the Ethernet cable, and they start sharing files, they start sharing stuff with each other. So now this as a whole can be known as a network. So what we can conclude out of this is two or more devices connected together can be considered as a network. Whether it doesn't matter if they are connected over a wire or a wireless connection. So it can be a wireless connection also. It will again be considered as a network only. So this is a network where a PCA is being connected to PCB. So this was a very basic simple example for this. And now if there is a person C and A and B are already there. Now let's say A and B were sharing stuff with each other, and C came into the picture and then they realized that C has some files which A wants to be with him. So now they want C to be connected with them. But when we talk about NIC card, which we will discuss later, so a PC has only one NIC card which can be used to connect devices. So in that case, we will use a device called switch. Switch is nothing but a device with multiple NIC cards. So we will connect PCC with this switch, we will connect PCA with this switch, we will connect PCB with this switch. And once these PCs are connected to the switch, A, B and C will be able to communicate with each other easily. So switch can be considered as a medium for their communication. Now, when C decides to communicate with A, how will he tell the switch that this information needs to be delivered to A? There has to be some address. We are calling it as A, but PC don't understand that. They understand something known as IP address. So IP address is the logical address of a PC, and you can consider it as a name of PC. So let's now understand how a IP address looks, and you must all have seen something like this before. This is a random IP address. So the IP address is of 32 bits, and there are 4 octets in IP address. These are called as octets. There are 4 octets, and each octet is of 8 bits. So when you multiply 4 with 8, you get the whole size of IP address, which is 32 bits. Now, this is something which we understand. This is the human understandable form. This form can be understood by the humans, but this is not something which a PC understands. We all know that PC only understands the binary language, and these IP has to be converted to binary. Yeah, so these has to be converted to binary to be able so that the PC can understand them, and you have to convert these IP address into binary forms. So there is a master formula for that which we use to convert IP addresses into the binary forms. So we will just simply take the example we just took, 192.168.2.1, and we will just try to convert this IP address into the binary form. So there is a master formula used for converting these addresses, which is you have to just simply write 2 raised to the power 0 to power 1. So 2 with the power of 0 is 1, then 2, 4. So you have to keep this in your mind while converting the IP addresses. This will make this very easy. But all you have to do is just simply take the first octet, the value of first octet, which is 192, and we will just simply try to make 192 out of these values. So if we take 128 and 164 and add them together, we get 192. So I have written 1 and 1 here to so 1 represents them as a on bit. So as we discussed, there are 8 bits. So you can see there are 8 bits which you can consider. So we are just turning the first and second bit as on, and the rest of them will be 0. So when you add these two, you get 192. Now if we take 168, so we will take 128, and if we add 32 in that, it will result in 160. And after that, so I am just turning the 32 one on. After that, we can simply add the 8. So the rest of the bits will be off bits, and we can write 0 for them. Now we will move to 2. So we'll just simply write 0 for all except 2. Then we have 1. Okay. So when we write these numbers together, we will get our binary form for the IP address, which is 11,000,000 dot 101,010,000, and after that, and the last one 000,001. So this is the binary form which a computer understands. So now I want you all to solve these IP address for me and let me know their binary forms in the chat. The first one is 192.168.10.12, then 150.10.11, 12.2 and 10.5.6.2, and the last one 172.16.15.128. So I want you to convert these IP addresses into binary form, and once you are done you can post your answers in the chat box. So I'm giving you a good 15-20 minutes. You can take your time. Amazingly done by everyone and very well tried. So let's just solve these here and you can verify your answers. So let's begin with the first one. So the very first one is 192.168.10.12. So for 192, we will take 128 as on. Yeah, we will take 128 as on, and after that we will take 64. Then rest of them will be 0. When it comes to 168, we will take 128. With that we will take 32 and 8. Then we have 10. 10 can be done by 8 and 2, and rest of them can be kept off. And the last one is 12. So 0, 0, 0, 0, 1, 1, and 0, 0. So we are taking 8 and 4 so that 12 can be, we can get the 12. So when we convert the whole IP address into the binary form, we get 1, 1, 0, 0, 0, 0, 0, 0 dot 1, 0, 1 and 0, 1, 0, 0, 0. Then after that 0, 0, 0, 0, 1, 0, 1, 0. And the last one, okay. So 4 times 0, then 1, 1, 0, 0. You can verify your answers with this. Now let's understand the second one, which is 150.10.12.2. So if we talk about 150, so first we will keep 128 as on. Then if we add 32 into 128, we will get 160. But the octet which we are solving this for is for 150. So we will add 16 to 128 and let's see how much we get. So we get 144 after after adding 128 to 16, and we are left with 6. So we can take 4 and 2. So this will result into 150. And the second one is 10. So that one is a simple one. We will take 8 and 2 as on, and the rest of them will be turned off. Then we have 12. We will turn 8 and 4 on, and the rest of them will be 0. Then the last one is 2. That's simple. We will keep 2 as on and the rest of them as 0. So this is the solution for the first one. Now I am writing the solution for second one. It is 1, 0, 0, 1, 0, 1, 1, 0. Then after that 0, 0, 0, 0, 1, 0, 1, 0. Then we have 0, 0, 0, 0, 1, 1, 0, 0, and the last one. So this is the conversion of 150.10.12.2. Now let's look at the third one, which is 10.5.6.2. So the first one we have is 10. Okay, this is 1, this is 2, this is 4, this is 8, 16, 32, 64, and 128. So now we have 10.5.6.2. So for 10, we will take 8 and 2 for 10, and the rest of them will be 0. For 5, we have 4 and 1. If we add 4 and 1, we get 5. And for 6, we can turn on 4 and 2. And for 2, we will take 2 as on, and the rest of them will be 0. So the binary conversion is here 0, 0, 0, 0, 1, 0, 1, 0, dot 0, 0, 0, 0, 1, 0, 1, then 0, 0, 0, 0, 1, 1, 0, and the last one is okay. So let's now understand the same for 172.16.15.128. Let's see how that's gonna work. So for 172, we will first of all take 128 as on, and we can add 32, which will result in 160. Now we have 160, we just need to add 12. So we can take 8 and 4 with it so that it can result into 172, and the rest of them will be 0. Now we have 16. 16 is there. We'll take 16 as on and the rest of them as off. Then we have 15. Now 15, for 15 you can add 8 plus 4, which is 12, then 2, which is 14, then 1. This ends up to 15, and the rest of them will be 0. Then we have 128. Simply we will turn on the 128 and the rest of them will be 0. Now when you write them together, you get the binary form of this. So that's 101, 011, 00 dot 0001, and the rest of them also 0. Then we have 0000 and 1111, and the last one 10000. Okay, so here we hand. Now you all know how you can convert the human form of IP address into the binary form. Let's move further now. Let's move forward and understand what are the different types of networks, how we configure network, what are the different types of communication, and everything else. So this was something about IP addresses. We will learn more about the IP address in the coming days. We will learn how ranges are defined by authorities for IP addresses, what are the available ranges for our use, and what are the ranges available for industrial uses. So we will talk more about this. You need not to worry. Now let's understand some basic things before that. Let's just learn what are the different types of network. So the first one we have is personal area network. You can call it as PAN. This is a network which you create personally for your own use. So you must have shared files over tethering or hotspot from your mobile devices to any other device. So that you can consider it as a personal area network. Then the next one we have is campus area network. So a network which covers a area of any campus which is specifically there for a campus. So you can just consider the college networks as a campus area network. That is known as campus area network. So the third one we have is local area network, which is known as LAN. So this can be configured in small offices, and any network within the range of, we can say, let's say 100 meters can be considered as a local area network. Then we have metropolitan area network. And the last one, wide area network, which is known as WAN. So metropolitan area network is basically a network between, let's say, a branch from different city where is connected to a branch of different city. So a network between cities or states can be considered as metropolitan area network. And when it comes to countries, we can consider it as a wide area network. So let's just understand this more specifically. Um, let's say there's an office and there are multiple PCs connected together there. So these three PCs are, we can call these three PCs in a LAN. So these are in a local area network. We can call it as a LAN. And let's say there's another office of same organization in another state. And there is also a LAN area network configured. Now, when you connect these two LANs together, you can call it as MAN as whole. So this network is now connecting two different states, and uh, we can call these LANs together as MAN, which is Metropolitan Area Network. Now let's assume that there is another MAN configured in a different country. So let's say this network is there in India, and there's another MAN configured in Dubai. Now if we connect India with Dubai, this will be known as WAN, which is wide area network. So you can now understand this more specifically. When we connect countries together, we call it as WAN. When we connect states together, we call it as MAN. And when the network is configured locally in the office, you can call it as local area network. So this was all about types of network. Now we will learn more about the types of communication you can make between devices. So basically there are three types of communication. So we are discussing types of communication. So the first type of communication we have is unicast, which is a one-to-one communication. Then we have multicast, which is one-to-many. And then the last one we have is broadcast. This type of communication is one-to-all. So let's say there are PCs here and there is a admin PC here. So if this admin PC just talks with PC A, we will call it as unicast, or you can consider it as a one-to-one communication which is being held with the admin PC with A. But if the admin PC communicates with A and B, but so then we can call it as multicast. As the communication is happening between one to many, you can see A and B both are getting communicated with admin PC. And if now the admin PC communicates with A, B, and C, then we can call it as broadcast. Now this is a broadcast. Some examples of broadcast can be when you listen to FM frequencies, radio frequencies for, then you can call it as a broadcast program. It is being broadcasted on a particular frequency and you connect on the same frequency so that you can hear the same. This was all about types of communications. Now let's understand everything about this thing, which is a cable. Now cable is used to connect two devices together. So there are some different types of cable which are used. There are some different technologies, there are some different protocols which has to be kept in mind before connecting any two devices. So we are now going to talk about cabling. So there are basically two types of cables available there in the market to connect devices. The first one we have is copper cable, and the second one we have is fiber cable. Under copper cable there are again two types, UTP and STP. Uh, Let me just show you some images so that you can understand this. So this is a picture of Ethernet cable, and this is the cable most used in the networking field. Then we have shielded and unshielded twisted pair cables, which I just mentioned. Under copper cables there are again two categories, which are shielded and unshielded. So as you see there is a shielding here, and yeah, so you can see a shield is there which is protecting the wires. And when we see the unshielded twisted pair cable, this is the UTP one and this is STP. So when we look at the unshielded one, there is no such shielding available there. As the name suggests, the shielding one has a shield and unshielded one doesn't has a shield. There is no protection there on unshielded one. Now since the shielding and unshielding is there, this affects the price and makes the shielded one a little expensive, whereas if we talk about unshielded one, these are little cheap. Okay, now at the end of these cables, there is a specific connector used to connect the wire with the device. So this connector is known as RJ45. Let me get a picture of that also. So this is a RJ45 connector. The cables are inserted into this, and a crimping tool is used to crimp the wires inside this. Then after that, this can be inserted to any device to make the communication possible. So you can see there are some pins there available on the wire. You can see there are 8 different pins. These pins are inserted in this RJ45 connector, and then this RJ45 connector is inserted to the device so that they can communicate with each other. So there is um, some protocol which needs to be kept into mind while inserting these pins to the RJ45, and let's understand what it is. So now there are again two different types of cables. We have crossover cable and a straight through cable. So there are two types of cable, straight through, then we have crossover cable. Okay, so straight through cable is used. Straight through cable is used between different devices. And what do we mean by different devices is we just discussed about a device called switch, which was there to connect different PCs together. I mean multiple PCs, which was connecting three PCs together, PC A and PCB, PCC. These were getting connected through a device called switch. So the cable which will be used between these two devices, which is the device number one switch and device number two PC, will be straight through cable. Why? Because there are some pins available on the NIC card. So we will learn what NIC card is. Let me again just show you the images of NIC card also, so that you can have a better understanding of this. So this is how NIC card looks, and if you see this, there is a port available so that the RJ45 connector can be inserted to this. And switch is nothing but a device with multiple NIC cards so that the devices can communicate with each other, and a multiple number of devices can be connected with each other. Yeah. So there are some pins available there on the NIC card of a device, and these pins are numbered from 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. And out of these 8 pins, the important one which we are going to discuss about are 1, 2, 3 and 6. So these pins act as a transmitter or as a receiver for the device, so that the information can be received or can be transmitted to the other device, or can be received from the other device. So we have 1, 2, 3 and 6. Let's say these are the NIC card. This NIC card is of a PC, and here also we have a PC. So we are here connecting two PCs together. We are learning why a straight through cable or a crossover cable would be required between same or different devices. So the first pin acts as the receiving one. I am writing RX for receiving and TX for transmitting. So the first pin acts for receiving one, and at the same like PCA, PCB's first pin acts receiving pin, and the second one also acts as the receiving pin. Then the third one we have as transmitting, then the sixth one transmitting. So when we take crossover cable, which is used between same type of devices, we connect the pin 1 with pin 3 and pin 2 with pin 6, then pin 3 with pin 1 and pin 6 with pin 2. So this is how a crossover cable works. Or we can say this is why a crossover cable is required between same type of devices. So that when PCA transmits any information from pin number 3, then pin number 1 of PCB can receive it. And if we say that PCA 1, 2, 3, 6 gets connected to PCB with the help of a crossover, a straight through cable, then in that case what would happen is the pin 1, which is the receiving pin, will get connected to the receiving pin of pin B. Then again the pin 2 will get connected to the pin 2. Then pin 3, which is the transmitting pin, will get connected to the transmitting pin. Similarly, for pin 6, it will get connected to the transmitting pin of PCB. So to avoid this so that the data can be transmitted, to make the data transmission possible from PCA to PCB, these types of cables are used, or crossover cable is used. More specifically saying, crossover cable is used, so that the one can get connected to 3, and if the PCB transmits something, A can receive that at pin 1. But when it comes to different type of devices, let's say we have a switch here instead of PCB, we have a switch connected with PCA. When it comes to a switch, then the pin number 1 of a switch will be transmitting pin. The pin number 2 will be a transmitting pin. Then we have receiving. Then we have receiving. These are the pins of a switch. So a crossover cable can be used between same type of devices, and a straight through cable can be used between different devices. So this is the reason we use different types of cables among different types of devices, so that the communication can be made possible. But now the new devices which are there in the market, now the NIC cards which are there in the market are available with a technology called auto MDIx. So what does this auto MDIx stands for? Auto MDIx stands for Automatic Medium Dependent Interface Crossover. And what is the use of this auto MDIx? So this automatically detects whether a crossover cable or a straight through cable needs to be used, and change the pin numbers logically so that the communication can be made even if the wrong type of cable is being used. So for example, if PCA is there and if PCB is there, and instead of being connected through a crossover cable, they get connected through a straight through cable. So auto MDIx will help them here, and will change the logical pin numbers and just make the communication possible with straight through cable. So this is a new technology which is there available on now most of the devices which are present in the market, and this helps a lot. You don't have to worry about the type of cable now, and you can just simply connect the devices with any type of cable and it will work. So this was introduction about cabling. Now we have something more about cabling, which are Ethernet standards. What are the different speeds available there in the market which can be used to connect devices? So the very first one we have is Ethernet, which supports the data transmission on a speed of 10 Mbps. Then we have fast Ethernet with 100 Mbps of speed. Then the third one we have is Gigabit Ethernet with 1 Gbps of speed. And the last one, 10 gig Ethernet with a speed of 10 Gbps. Now, if we talk about Ethernet and fast Ethernet, there are 8 pins, out of which 4 pins are used for data transmission and receiving, and the rest of the 4 pins are used for the management of voltage. So out of the 8 pins, we just discussed about 1, 2, 3 and 6. So this was the reason why we discussed about only these 4 pins and not about all of them. And in case of gigabit Ethernet and 10 gigabit Ethernet, all 8 pins are used for both data transmission and for voltage management. So in case of Ethernet and fast Ethernet, we have 8 pins, out of which 4 are being used for data transferring and 4 are used for voltage management. And in case of gigabit Ethernet and 10 gigabit Ethernet, all 8 pins are being used for data transfer and voltage. So these were some of the Ethernet standards which are defined by IEEE, Institute of Electrical and Electronics Engineer. So these are defined by IEEE, and these are available there in the market, so which can be used among devices to make data transfer possible. Now, since we are done with introduction about types of cabling and the types of communication, we learned about how we can convert an IP address to binary form, which is a computer understandable form. Then before that, we learned about switch. Now to understand how much switch a useful is, we need to understand something about a device known as hub. So before switch were introduced, a hub was something which was being used to connect multiple PCs together. So let's say there are 4 PCs connected, A, B, C and D. All these PCs are connected with a hub. So just for information, hub is no longer in use and only switch are being used now. And why this hub is no longer in use, that we are going to discuss now. So what hub used to do is, hub only broadcast the information. Doesn't matter if the information is only for B or C or let's say for D. If A sends something to this device hub, it will send it to everyone except A. So what happens here is, if A sends any message for B, which is particularly for B, then what will hub do? He will send it to C, he will send it to D and to B. And since the message is for B, B will accept it and D and C will drop the message. So this was something done by hub, and this is the reason why it is no longer in use. It leads to the wastage of bandwidth, uh, as every time you send something, the hub will broadcast it to everyone. But now, since switch is being used, switch works something differently. And if the message is supposed to be delivered to a PC, let's say PCB, then it will only go to PCB, not to C or D. And if B replies something, then it will only go to PCA and not to any other PC. So this was an introduction about hub. We will not very much discuss about it since it is no longer there in the use. Then next we have is IP classes. So as I said, we will discuss more about IPs. There are some IP classes available there in the market which are used. So there are basically 5 classes: class A, class B, class C, class D, and class E. Class A is ranges from 0 to 127. Then class B ranges from 128 to 191. Then the C goes from 192 to 223. Then we have class D, which is therefore from 224 to 239. Then the last one, 240 to 255. Now why from 0 and why till 255? Let's understand this first. So as we discussed, there is a master formula there, which was this. And the values of these are 1, 2, 4, 8, 16, 32, 64, and 128. So if you turn all the bits, which are the 8 bits of one octet, if you turn all the bits on, you will get 255 as your result. So you can just simply add them together and the result will be 255. And if you turn off all the bits, or we can say we put 0 for all of them, then the result will be obviously 0. So this is the reason why these ranges are available there from 0 to 255. We will discuss this more deeply in the coming classes, why class A ranges from 0 to 127 only, and why class B is there from 128 to 191. We will discuss this in the coming days. We will discuss how many out of these 5 classes are available there for our use, and how we can use these classes to make communication between devices possible. So I hope today we are ending the session a little early. I hope you guys enjoyed the session and you got to learn something out of this. So thank you so much for joining in. We will ending early today, and let's meet tomorrow at the same time, which is 5 p.m. And let me just check the group if there is any questions. Just quickly scrolling the chats so that if there is any question left unanswered, I can answer that. Okay, so sure, Ranjan. Uh, so how you can identify the number of pin is, it's simple, very simple. The very first pin is the number 1 pin and the last pin is the 8 pin. You just have to put your cables in such a way that you don't have to worry actually more about this. We will discuss this more deeply. There are some color combinations between cables which you have to take care of before inserting the cable into the RJ45 connector, and we will be discussing this about later in the classes. Yes, switches are there available with auto MDIx, and you don't no longer have to worry about straight through or crossover cables. Yes, we will be discussing about how switch works, how a switch identifies whether it has to send the packet to PCB or PCC, and how switch identifies what the packet is meant for. Yeah, sure. Auto MDIX is nothing but a technology which is there available on new NIC cards, and it makes the communication possible even when devices are not connected with the supposed cable. So let's say if a PC is connected to another PC, which we just discussed, just a minute. So auto MDIX stands for, yeah. So automatic medium dependent interface. This is the full form of auto MDIX. Someone was asking, and what it does is it makes the communication possible between devices even when they are not connected with the type of cable we just discussed. So for example, we have a PCA here and PCB here, and they are supposed to be connected with a crossover cable since they are same type of devices, since their 1236 pin acts as receiving and transmitting at both of the ends. But even if you connect them with a crossover cable or with a straight through cable, the communication will be possible. Why? Because of auto MDIx. Okay. Yes. So the rest of the four pins are for voltage management. You are correct. I hope this is clear now and the use of auto MDIx is clear now. So we are ending the session now for today. You can put your doubts in the chat group, and let's meet tomorrow at the same time, 5 p.m., and discuss more about networking, learn more about networking, dig deeper into the world of networking. We'll just, there are a lot of things which are yet to be discussed. We will discuss everything in the coming classes. So, thank you so much for joining in. We are ending the session now. Uh, it was a great time with you all. Thank you.